Alrighty folks, in this video we're going to go over the applications of quadratic functions. Namely, I want to show you how to calculate the maximum revenue of a quadratic function, and I'm also going to show you how we determine the break-even point for a profit function. Alright, so just a quick little recap here. So in previous videos, remember we talked about how we find our revenue function, which we denote R of x. So your revenue function is your quantity times your price. And so for us, that's going to be quantity is represented by the variable x. Our price function is denoted by little p of x. And then our profit function, we find that by taking the revenue function, r of x, and subtracting away the cost function. All right. So with that as our background, let's talk about a little bit of college algebra recap. So a quadratic function has the form ax squared plus bx plus c. So that is what we call the standard form of a quadratic function. The graph of a quadratic function is called a parabola. That's that U shape, if you're used to that. And the vertex of a quadratic is an ordered pair, I should say. And it's either going to be a min or a max. And the determination of whether it's a min or a max depends on whether or not that parabola, that U shape, is opening upwards or if it's opening downwards. So, for example, if the parabola opens in this fashion, an upside down parabola, we're going to have a maximum, and that max is going to be the vertex. Or the parabola could open upwards. In this case, we're going to have a minimum, and that's also the vertex. So how do we find the vertex? Well, the vertex is an ordered pair. To get the x-coordinate of the vertex, what you do is you take the opposite of the b and you divide it by 2 times a. So that's why it's important to get your functions in the standard form that we mentioned earlier, ax squared plus bx plus c. And then once you've gotten that x-coordinate for the vertex, what you simply do is you plug it into your function for x, and then that's how you get the I guess the y-coordinate is what we call that. So that's just really just f of x. That's just taking that x value and plugging it in. Let's get into a quick example here. Given the following price demand function, find the maximum revenue and the number of units that must be sold to achieve this maximum revenue. All right. So the first thing we realize is that they don't give us the revenue function, but they give us a price function. So we know from before that to get the revenue function, we must multiply that price function through by x. So I'm just going to take x and I'm going to multiply it through to my price function, which is 150 minus 7.5x. Distributing my x value here, we get 150x minus 7.5x squared. Then what I'm simply going to do is I'm going to rewrite this in standard form for a quadratic, which means I'm going to put my x squared term first. So don't forget the negative that comes with it. So a negative 7.5 x squared plus 150x. That is our revenue function. Okay? So there's our revenue function. So now we need to find the maximum revenue. So how do we do that? Well, we need to find the vertex. That's what we need to do. So as I said before, the x-coordinate of your vertex can be found by taking the opposite of b and dividing it by 2 times a. All right. Well, what's our b? Our b in this case is a positive 150. So the opposite of that is a negative 150. So it's a negative 150 over 2 times a. A in this case is a negative 7.5. Okay. So working this out, we get a negative 150. 2 times a negative 7.5 is a negative 15. And if we divide these out, we're going to end up with 10. So the x-coordinate of the vertex is 10. And if you refer back to previous videos, we said that the x value represents the number of units that we're selling or that we're producing, depending on the application. Well, since we're talking about revenues here, this X value represents the number of units that we must sell in order to get the maximum revenue. Now keep in mind that's not the actual maximum revenue. To get the maximum revenue, the dollar value, what we need to do is calculate what I like to call the y-coordinate of the vertex. In our case, what this means is we need to take that value of 10 and we need to plug it into the revenue function. Okay, that means that we need to calculate a negative 7.5 times 10 squared plus 150 times 10. So all I did was I took my X value and I plugged it into the revenue function. I want to find the max revenue. So let me pull up my calculator really quickly. Okay, so it's a negative 7.5 times 10 squared plus 150 times 10. All right, close that up. We hit enter and we get 750. Okay, so the y-coordinate of the vertex, or r of 10, we got 750. So what does that mean? That means that the maximum revenue that we're going to generate from this product is $750. And it turns out that the number of units that we must sell is 10. So when you're doing your homework, when you're doing your work, make sure you understand, are they asking for the number of units I need to sell to get to the maximum revenue, which is the X coordinate, or do they want the actual maximum revenue in dollars, which is your Y coordinate? All right. So that's how you find maximum revenues. There's also a concept called the break-even point. So the break-even point occurs when your revenues equal your costs. So break-even means you're not making any money. You're not making money. You're not losing money. And so when revenues equals cost, that's also the same as saying, hey, my profits are equal to 0. So to find your break-even point, what you do is you set your profit function equal to 0. All right? And let me show you how to do exactly that. Here we go. Another example. Suppose that a company produces a product that has fixed cost of $120 and variable cost of $15 per unit. Assume the price demand function of the product is 150 minus 7.5x. Find the break-even points. So what we need to do here is set the profit, set big P of x equal to 0. Well, we don't have our profit function written explicitly. Well, we have some information about costs and we have our price function. So what we need to do is, what we did in a previous video, is kind of build this profit function from scratch. So from the last problem, we know that the revenue function will be x times your price function. Well, the price function happens to be the same as the previous question. So it's going to be x times 150 minus 7.5x. And as before, as we distribute the x, we get 150x minus 7.5x squared. That's our revenue function. Remember, your profit function is revenues minus cost. So now we need to come up with the cost function. And so here they give us enough information so that, so that we can come up with the linear cost function. We have fixed cost of $120 and we have variable cost of $15 per unit. So we know that the linear cost function must be $15 times X units plus the fixed cost of $120. Now we can calculate our profit function. So what's the profit function? It's your revenue, 150x minus 7.5x squared, minus the quantity, but in parentheses, your cost function, which is 15x plus 120. All right, let's distribute our negative. So minus 15x minus 120. I'm distributing my negative. And then I'm going to combine like terms and rewrite this in standard form for a quadratic, meaning I'm going to write my x squared term first. So negative 7.5x squared. I'm going to next take 150x and subtract away 15x. So 150 minus 15, that should give us a positive 135x. And then minus the 120. So here we go. That is our profit function. That is our profit function. So how do we find the break-even points? Well, the break-even point is where your profit function equals 0. And so to find that, we look at this. This is not going to factor. And so what we're going to use is the quadratic formula on how to solve a quadratic equation. So I know it may have been a while since some of you guys have used this before, but to refresh your memory, the quadratic formula says if you're trying to solve this, ax squared plus bx plus c equals 0, which is what we're trying to do, set our profit equal to 0. It turns out that the solutions to this is x equals, it's the opposite of b, plus or minus square root of b squared minus 4a times c over 2 times a. That is your quadratic function, or your quadratic formula. Okay. So what we're going to do is we're going to take our profit function, we're going to set it equal to 0, and we're going to solve it using the quadratic formula. So what does that look like? So that means that x equals, so the solution to negative 7.5x squared plus 135x minus 120 equals 0 is, I take the opposite of the b. So our b is a positive 135, so the opposite is a negative 135, plus or minus the square root of b squared, so 135 quantity squared, minus 4 times a, our a is a negative 7.5, times c, which is a negative 120, all over 2 times a, which was the negative 7.5. All right. Now all that's left for us to do is to figure out the numerical values of this. And so I won't go too deep in the quadratic formula, but there's this thing called a discriminant, which is what I'm highlighting here. That tells you how many answers you'll have to this, how many real solutions you'll have to this. But what I'll do right now is I'm just going to throw this into the calculator. So here we go. Open up my calculator. All right, so I'm going to do open parentheses. So I want to set up parentheses for my numerator. I'm going to do a set of parentheses for the denominator. So it was a negative 135. I'm going to do the plus version first. Negative 135 plus the square root of 135 squared minus 4 times a, which is a negative 7.5, times c, which was a negative 120. Okay, let me just double check those values. Yep. Okay, I'm going to get out of my square root, going to close parentheses. Then I still need to divide this by, let's open up another set of parentheses, 2 times a, so 2 times a negative 7.5. I know you guys can't see the full thing, but everything looks to be correct. Hit enter, and there we go. I get a 0.94. Let's round that to 2 decimal places. So 0.94. That's one solution here. Oh, wrong color. And let's see if we get a second solution. So the next solution is going to be, instead of using the plus, I don't know if you guys can see my cursor here. Instead of using the plus, now I want to use the minus. So here's a quick little trick on your calculator, at least on the TI-84s. If you don't want to retype that whole thing again, because all I want to do is I just want to change this plus to a minus. If I hit second, enter, what that does is that cycles through all of my previous calculations. And so what I want to do is I want to take my cursor now and move this thing over to that plus right here, and I want to change it to a subtraction sign. Oh, let me say this, y'all. Subtracting is different than negatives in your calculator. Anytime you're dealing with the negative, make sure you're using the button at the bottom. When you want to subtract something, that's when you use the button to the far right. Okay, let's calculate that. So let's enter on that. And the other one, we get a 17.06. Okay, 17.06. Okay, so what does this mean? We got two values here. So what that means is the following. Let me actually draw you a picture here. So our profit function is a quadratic, right? We can see that because the degree, the highest power is 2, right? It's a quadratic. And because since a is negative, it means it's opening upside down. And in fact, what we found here with these two x values is that we have found the x-intercepts, or the zeros of that parabola, of that quadratic function. So let me just draw this here. So this is what our profit function is doing something like this, where right here, this ordered pair, or this x value is a 0.94, and then the rightmost x-intercept right here is the x equals 17.06. All right. So what are we saying here? So the break-even point is, like I said, is where your profits equal 0. So what are we saying? We're saying that we are going to make money everywhere that profit is above the x-axis, everywhere that green curve is above the x-axis. So the break-even points that we're going to have here is, and this is what you're going to have to put into your homework, the break-even points, because you can't have a partial unit. All right, you can't have a partial unit. I can't sell a 0.94 of a unit. So what this means is that I'm going to break even for the next unit that's after 0.94. So my break-even points are going to be when x equals 1 unit. I'm going to break even at 1 unit. And then also, right here at this 17.06, I'm going to break even slightly before that. So I'm also going to break even at 17 units. So what I'm trying to say is going to be a little confusing in your homework, but what I'm saying is what you do is, the way that the parabola works is that you round up your left value, you round that up to the nearest whole unit, but then what you're going to do is you're going to have to round back the second unit, if that makes sense. So round up the left x-intercept, round down the right x-intercept. So our break-even points will be 1 unit and 17 units respectively. All right, folks. Hope this helps you out with the homework. I'll see you guys in the next video.